Guys, happy Friday. You made it to the end of the week. Congratulations. I'm going to go over our first macromolecule. Real quick before I start, remember that a macromolecule just means macro, large molecule. That's it. It's just a very large molecule. So the first one that we're going to go over is a carbohydrate. Now, we probably have all heard of carbohydrates before, but I want you to know what a carbohydrate is. So let's break down the word carbohydrate. Carbo means carbon, and hydrate means water. So when we talk about carbohydrate, there's always going to be carbon, hydrogen, and oxygen. And the carbons, hydrogens, and oxygens are always going to be in a 1 to 2 to 1 ratio, always. So let's look at an example. Glucose is something that's very common if you study photosynthesis, and glucose is a carbohydrate. So glucose, the chemical formula, is C6H12O6. If you look at 6-12-6, that's a 1 to 2 to 1 ratio, and it's made of carbons, hydrogens, and oxygens. That's how we define a carbohydrate. So first off, let's look at the monomer. And remember, a monomer is just a smaller subunit, a smaller molecule that can be bonded together to build a larger molecule. So for carbohydrates, the monomers are monosaccharides. Let's break monosaccharide down. Mono means one, and saccharide means sugar. So monosaccharide means one sugar molecule. And an example of a monosaccharide, again, is a glucose. It is one sugar molecule. Now let's look at the polymer. Remember, a polymer is monomers bonded together. Polymers are only, oops, sorry, that's my alarm. Polymers are only monomers bonded together. That's it. Again, the difference between a polymer and a macromolecule is that a polymer can only be monomers bonded together. A macromolecule can be monomers bonded together or other smaller molecules that aren't the same bonded together. Polymers have to be the same molecules bonded together. So the polymer for carbohydrates is polysaccharide. And let's break polysaccharide down. Poly means many. Saccharide means sugar. So what do you get? Many sugar molecules. An example of a polysaccharide would be starch. Starch is just a bunch of glucose monosaccharides bonded together in a straight line like this. That's it. The last thing I want to point out for this slide is that the structure of carbohydrates is always going to be the same. So you're always going to have a carbon ring. This is a carbon ring. It's a ring shape made of carbons. And that ring is always going to have hydrogens and oxygens bonded to it. That's it. That's how you recognize what a carbohydrate looks like. So you can memorize all the information on the last slide, which would be great. But ultimately, what I want you to realize is, why do we care? Why do we care about carbohydrates? What does that mean for us? Well, carbohydrates for us, for other animals, and for plants is a very quick, reliable, easy source of energy for us to access. We are able to break down carbohydrates very easily. We're able to metabolize it very easily. What does that mean? That just means we're able to break carbohydrates down and use the parts of the carbohydrates to do certain body functions. So let's look at a Red Bull. The nutritional facts for a Red Bull state that there are 0 grams of fat, less than 1 gram of protein, but 27 grams of carbohydrates, 26 of which are sugars. And that makes sense because carbohydrates are a fast, quick, and easy source of energy, and Red Bull is supposed to give you energy right away. So it makes sense that if you want fast, quick energy, it's full of carbohydrates. If you have any questions about any of this, please let me know. I'll be on the Zoom. I hope you guys have an awesome weekend. I'll see you on Monday.